Yeah. You want what? Like a whole pad? You want like crazy sticky notes? All right. Uh-oh. Miss Thorpe got those for me in England. All right, guys. Warm up. Hello. Hello. We are recording here. All right. Do you remember how we found the vertex? Remember, we could complete the square here. Did we decide that was the funnest thing to do? When it had a -3 out here, it wasn't as fun as we wanted it to be, right? So if we find the vertex, do you remember the vertex finder recipe? There we go. So what is the opposite of B on this question? -18. Twice A would be -6. So everybody okay? That was 2 times -3 out there. And then when we divide, we get 3. So x equals 3 is actually the axis of symmetry for this. Whoops, I can't write that ever. I don't know why. And then the vertex is at 3 something. Okay. So how do we find the something? Yes, we put 3 back in. So we have -3 times 3 squared plus 18 times 3 minus 1. I'm thinking I might need some help here. -27 plus 54 is 27 minus 26. No? Yes? Okay. So the vertex is at 326. I don't really remember what else the directions said to do. I think draw a sketch or something, which we could do that. But can you rewrite this in vertex form? That's kind of what I wanted to review. How would we rewrite this in vertex form? This is vertex form. Is that helping anybody? We would have x minus 3 from the vertex squared. The plus k would be what? Plus 26. What's the trick though? Keep the stretch. So we still need that -3 out there. So if we did go to graph it, it's over 3 and up 26. So it's way up here somewhere. And it's opening how? Down and really skinny, yes. Okay, so there's my little graph up in the middle of nowhere. Now, I don't have the directions on this slide. Did we pretty much cover everything we were supposed to? Vertex, graph, axis of symmetry. Okay. What are they trying to trick us with on this last one here? Ooh, so what are A, B, and C? A is 5, B is -6, and C is 12. We could just rewrite it. So the axis of symmetry or the vertex would be at what? Opposite of B would be 6 over twice A, which would be 10. So 3/5 or 0.6 sounds good to me. Okay, can we just use the decimal to type it in, see what we get? I went back to the original one, I guess, but yeah, I am going to use my calculator for that. 12 minus 6 times 0.6 plus 5 times 0.6 squared. I got 10.2. Did anybody else get 10.2? Okay. Did someone else get 11.4? Oh. Did you figure out what you typed in wrong? Okay. So the axis of symmetry is at x equals 0.6. If we graphed it, it goes over 0.6 and up 10.2. Which way is this one opening? It's open and up and real skinny, right? Yeah, I didn't make mine very skinny, but all right. Could you rewrite it in vertex form for me? Just practice one more time. Y equals Good job. She remembered the stretch. Yep. You did great. She said 3/5 and 51 halves. Is that right? Fifths. Yeah, 0.2 would. So she did fractions. Nicely done, Madison. Anybody questions on that? Does that seem okay, Patrick? You kind of remember doing this stuff before? Okay. All right. Today is stuff you probably didn't do before. You may have done a little bit of this kind of stuff along the way. Honestly, it's been a few years since I taught Honors Algebra 2. I don't think they did this in regular Algebra 2, so some of you may have seen it, some not. What we're going to do is we're going to first start with vertex form and put in the vertex from the graph, and then we're going to put in another point on the graph. It can't be the vertex because we want to solve and find the stretch, so it needs to be a point that has stretched, okay? If we put the vertex back in, there would be no stretch at the vertex. So for this graph, it looks like 2, 1. Does that seem okay? And we're going to have to kind of make up another point, it looks like. Does it look like 2, 1, 2 is a point on there, maybe? Oh my goodness, I didn't write that well. 1, 2, there we go. All right, so can anybody write it with an A in it for the stretch? What would the rest of it look like? Since this is the vertex. X minus 2 squared plus 1. All right, so we're going to put in another point. I picked 1, 2 and hope that this works out nicely. Where am I going to put the 1 and the 2? The 1 is the x value and the 2 I'm going to put in for the y value, right? So I'm going to have 2 equals a times 1 minus 2 squared plus 1. What are some things students might forget to do at this point? Simplify, square, what else? A common mistake is this comes out 1, but they want to simplify all of this. Can you simplify all of this together? This piece right here is multiplied by a, right? Everybody see what I'm talking about? So we're going to have to like subtract the 1 and then divide. Okay, because on this one it isn't going to make a lot of difference because it's going to be a 1, I think. 1 minus 2 is negative 1, squared is 1, right? So we have 1a plus 1 equals 2. So what's a? If I subtract, I get 1a equals 1. So a is just 1. So is there any stretch on this parabola? No, it's a positive 1, so it's opening up. So if we rewrite it, you can put in a is 1, or you could just leave it off altogether and say this is the equation. All right, so while I wanted you to see an easy one to start with, also you didn't necessarily learn anything, right? Because it didn't really have a stretch. So let's try one that definitely shouldn't have a positive 1 in front, right? All right, I'm thinking there's a intersection there, and can you maybe tell what that ordered pair would be? It looks like negative 2 something. What do you think? 1, 2, 3? All right, so the vertex we're thinking is at negative 2, 3, and then it has some x-intercepts or some other points we can use in a second here. Who can tell me what it looks like with the negative 2, 3 in? Y equals a, then what? Okay, x minus negative 2 would be x plus 2 squared plus 3. Good job. Everybody okay with where we got that? Put the vertex in. So far, so good? All right, now you could pick any other point on the parabola. Do you want to use negative 1, 0 or negative 3, 0? Negative 1, 0? Okay, totally doesn't matter. If we use negative 1, 0, where's the negative 1 going? For the x, right? and the 0 is going in for the y. So we have 0 equals a times negative 1 plus 2 squared plus 3. So we have 0 equals negative 1 plus 2 is 1, squared is 1. So that's 1a plus 3. Don't try to add that 1 to the 3 is my concern. Because this is multiplied times a. All right, so if we subtract, we get a is negative 2. Well, were we pretty sure it was negative? Did I do something wrong? Why is everybody looking? Negative 3, maybe? Okay, thanks. I'm like, I subtracted, but there's from 0, Hofbauer. Okay, sorry. Yeah, let's go with negative 3. Thanks for looking confused, so I knew I did something stupid. All right. Does that seem... I definitely needed to be negative, yes? Okay. Do you remember my funky little rule about when you go over 1, you would square it and go down 1, except that it's a 3 now we're thinking, so did it go over 1 and down 3? Does that work for the graph? Did it go out 1 unit and down 3? Seems okay. All right, so final answer would be y equals negative 3x plus 2 squared plus 3. This concept of writing as much of the equation as you can, and then finding another point to find the stretch and plugging it back in, solving for the stretch and putting it back into the equation, is a really big part of pre-calc, and it's worth a lot of points on the SLO, okay? I'm not sure it was done with a parabola on the SLO, but we're going to do the same thing with polynomial functions. All right. So, do you want to try this one on your own? Anybody want to go to the board and try it? Sure. Yeah. Go for it. Some of you, I bet, used 0, 0. Did you come up with the same answer, though? Good job. Yes. Okay. Okay, so you wound up with, when you plugged it back in, you had 0 equals what? Okay, I think this is negative 2, negative 2. I think you started with the vertex wrong, maybe? Did everybody get it otherwise? So I don't think you did anything wrong other than that, Patrick. You just started with the vertex at negative 3 instead of negative 2. Good job. All right, everybody feel okay about that now? The next questions are the same. Vertex through this point, there's just no picture, right? So should we do D or E? I don't think we need to do both. Let's do E. Okay. So, Andrew, tell me what to write to start us out. You're fine. Okay, I was just going to write this one at first and then the +5, right? But then you're absolutely right. We're going to put in the 4 here and the 6 over here. So we get 6 equals 4 minus 2 squared plus 5. I liked, Madison did that one, right? Okay, I liked how she wrote this, rewrote it with that in front. So 4 minus 2 is 2, squared is 4, yes? Okay, so then subtracting, I got 1/4. Did anybody else get 1/4? Okay, so if I were to think about sketching this, it's over at 2 up 5. And at 4, it's only up to 6. So that's seeming pretty flat, guys. If it's gone out to, seeming pretty flat to me. Does a 1/4 seems like it would be appropriate? Okay. So final answer, 1/4 x minus 2 squared plus 5. So you guys could do D or one like that on homework. All right. Let's talk about graphing and doing these algebraically, but these are kind of application problem that students usually like because they can do them on the graphing calculator. But I'm also going to talk about how you could do it without using the graphing calculator. But I like to call these throw up problems. Not because they're like vomit, but they're like throwing something up in the air, okay? From the top of a building, a toy rocket is shot upward with an initial velocity of 132 feet per second. The formula below gives the height of the rocket at time t. Assume t equals 0 when the rocket left its launch pad. And it's talking about height in feet and time in seconds. How tall is the building? It's shot from the top of a building. How do we know that? Some of you know the formula is negative 16t squared plus initial velocity times time plus initial height, right? But if we didn't know that, that's where it was launched at, t equals 0. If we put in t equals 0, we would get out what? 60. So 60 feet is how tall the building is. If we're going to do this on the calculator, we can think about the fact that it should start at 60, right? As it's going up. Okay, how far above it was it 3 seconds in? What if I wasn't using a graph? How would I find its height at 3 seconds? Negative 16 times 3 squared plus 132 times 3 plus 60. If we actually graph it, we can just trace until 3 seconds, yes? And that'll tell us its height. Same at 8. I vote we graph it. What do you think? Okay, the big thing about graphing in pre-calc is going to be all about finding an appropriate window. An appropriate means, and it's on that was on the SLO test, appropriate means that you're not showing me things that make no sense. All right, something important just popped up on my screen. Can you guys see this at all? You might want to turn the light off by the phone there. But this plot 1 is darkened in. That means I have a stat plot turned on still, and it's probably going to interfere with my graph. So if you turn to the y equals and you have any of these darkened across the top, just go up onto them, hit enter, and then if you go back down, it should not be darkened anymore around that plot. Or you could go second y equals and make sure they're all turned off. All right, now I'm going to put in the equation, negative 16x squared. What was it, guys? 132x? Mine's covered up. Is that what it said? Plus 132x plus 60. Okay. For an appropriate window, what is x representing? said up here, right, that x is t, so it's time in seconds. So here's my question. Can you have negative? No. So an appropriate window will start at 0. If you want to go a little bit in the negative, 1 or 2, so that you can see where the axis is better on your screen, I'm fine with that. I would not count that as an inappropriate window. But if you put in -10 to +10, okay, that just tells me you just did a Zoom standard or something, okay? Because you weren't thinking about the fact that you can't have negative time. All right, second y value is height of this. And what do we know about it? It starts at 60. I'm still okay with you saying 0, but you don't really need negative height, right? We might want a little bit because I think we're going to want to know when it hits the ground, but I'm going to start with 0. All right. Time. Let's go back to x. How long until you think this might hit the ground if you shoot a rocket up? Just throw something out there. Don't cheat and tell me what you found on your calculator already. What would you have started with? 15? Okay. And if it started at 60 and it's going up, what would you have started with for a height? Anybody? What? 150? Is that what we said? Okay. If we put in the window we thought might work, 0 to 15, scale doesn't really matter. It's how many tick marks you're going to get between 0 and 15. This is going to try to count by ones. It's fine. I don't care. Then we said 0 and 150 for the height. And if you're counting from 0 to 150, you might count by something other than ones. But the scale, again, I don't care. I'm not grading you on scale. Okay, if I put a 10 there, whatever. Remember, the scale is just how often do you want it to put a little mark on the graph paper? All right. Well, I can see it go up and I can see it come down. I can't see the top. But this is an okay window in terms of time. I would be okay with that. It goes past where we need it to, but that's okay. But what do I need more of if I can't see the top? Is that x or y that needs to be increased? The y maximum, yes? So someone said 300. Did you say 3? It's 350. You guys have already been messing around? Okay. 350 is nice. We can see the top. So I would say if you had done maybe 0 to 10 and 0 to 350, that's about as snug as you would want it to be. Anything after that is fine. Anything bigger than that, except if you start putting a bunch of negative stuff in that doesn't make sense. Does that seem okay to everybody? Understand what I'm saying? Okay. Y equals negative 16x squared plus 132x plus 60. Just okay. So here's my sketch. I'm going to put, and it's going up and coming down. Oh, that's awful. Okay. How did we say we could find, trace is my friend now? I could use the table, but I don't have to keep switching back and forth. If I just do trace, I go to 0, enter. That tells me it was 60 feet. Then I wanted to know where it was at 3 seconds. If I hit 3, enter, I got 312. Did you get that? What was the other one it asked? 8 seconds or 8? 8 seconds. I got 92. Yes? You can look at the table, but then you got to scroll around in the table. We could just type with the trace button. If I went trace 3, I already forgot. Somebody remind me. What was it at 3? 312 or something? 312 feet. And then when I went trace 8, it was at 92 feet. At what time did the rocket hit the ground? Does anyone know how we'd have to do that algebraically? Yes, the height would equal 0. So we'd have to go 0 equals negative 16t squared, x squared, whichever, plus 132x plus 60. I'm thinking that's looking like a quadratic formula question. Anybody really excited about solving that?
Yeah.
Not so much, right? What are we going to do on the calculator? Well, we can trace around. What do we want to know? Yes, we want to know when y equals 0. Is it going to let me find y equals 0 nicely? Very exactly? Not with the window I have set up. If you look at the table, it's only going to find between what 2 seconds hit the ground. All right, in Precalc, guys, I need you to be able to find where it actually intersects. Does anybody know how to do that? It is called a 0 because it's where it's an x-intercept is also called a 0. So we're going to go second trace, and we're going to pick 0. Now, it gets a little hairy because it asks us a couple weird questions. It asks left bound, and then it's going to ask right bound. Now, it seems weird because left bound and right bound can mean above and below, okay? But we just need it to be to the left of. In other words, we're looking for x to cross somewhere to the right of this. So I'm going to just hit enter. Anywhere where the cursor is to the left of the x value I want to find. And then if I trace to the right, I don't have a good window for doing this. But notice my y value is negative now. Does that mean I've crossed the x-axis? So I've gone to the right of where I need to be. Guess doesn't matter. So if I hit enter, I got 8.68. Did someone else do that and get that for 0? Does anybody never use that 0 function before to calculate and find the 0? Can I show you a little trick that I use all the time, guys? I hate cursoring around on a graph. So if I had been tracing on this graph and I saw, okay, so the closest I can get is like here, 8.6, and then it turns negative. This is what I would have done. Is everybody paying attention? Somebody can turn the light switch off by the phone, you'll see better. But if I say find the 0, which is choice 2, when it says left bound and right bound, guys, you can type a number in there, okay? If I know it's somewhere between 8 and 9 seconds, instead of scrolling around, I can type 8 as my left bound and 9 as my right bound. And it's looking in between these two little arrows up here. And when I hit enter, it finds it at 8.68. So you don't necessarily have to scroll around. I also will tell you at this point, I would have changed my window. I would have made some negative y, like negative 50 maybe even, so that I could see when I'm tracing that it doesn't cut off my whole picture. Do you see what I'm talking about? I would have moved it up a little bit on the window. All right, so what did we find? 8.7 roughly, 8.68. Was that right, guys? Okay, 8.68 seconds. What time did it reach its maximum? Wait, what is its maximum? Where is that maximum at? What's the top called? The vertex. Do we know a recipe to find the vertex? Yeah, we can use the calculator, but how could we have done this without a calculator? Not factor it. How do you find a vertex? Negative b over 2a is the answer to this question. The opposite of b would have been negative 132 divided by 2a, which would have been negative 32. So if I went back to the home screen and I did 132 divided by 32, because they're both negative, I got 4.125. All right, but how do you do it on the graph? Because that's how you all want to do it. I know that. Second trace. What do we? Why 4? Okay. The vertex will either be the max or the min, depending which way it's opening. And Sam says it's opening down, so we need the top point, so it's the max. Okay. Now, again, I don't like to scroll around, guys. I'm going to type a left bound. I'm going to say it's somewhere between 0 and where it hit the ground about 9 seconds in. Did I get the right answer? Okay, I got some little garbage there. It's 4.1250012, but it's really just 4.125. It has to do with the fact that I left such a big amount of space in between because it's approximating based on my guessing. So if I did it again and say find the maximum, and I arrow a little bit to the left and hit enter, and I go to the right and hit enter, this time I got it even worse, 3.124997. Okay, should be 3.125, right? Did some of you get exactly 3.125 when you did maximum? The calculator does what it calls repeated iterations to find the maximum. Are some of you not getting that at all? No? What did you get for the maximum? 4 point what? At the maximum? Exactly 4.13, or you rounded, or? Okay. 4.125 is the exact answer because we did it algebraically. But if you round it, that's fine. But again, if I calculate the maximum somewhere to the left, to the right. Okay, this time I got exactly 4.125, which is the right answer. Okay. So 4.13 I would take. I'm not saying I wouldn't. That's fine. It's basically really 4.1 seconds, right? Either way. All right, and the maximum height it reached at that point was 332.25. And again, we would have found that by putting in 3.125 into the equation. If we wanted to do it algebraically. Are we getting there? Anybody need help? Goofball. Are most of you really good already with that on the calculators buttons? Anybody doesn't feel comfortable with the calculator? All right. So you already wrote this down, yes, on Friday, but you can go and finish worksheet 7 now. Remember, I told you on Friday there was only a couple questions you were ready for. So make sure you go back and do these questions on worksheet 7. These are not the problems that are written on the gold sheet, so please, Patrick, write these down. Because I changed some of the numbers. 1, 6, 7, 11, 14, 15, and 16. You're getting it from somebody? Okay. I'll just circle them on worksheet 7, but everybody got them now? All right. The other thing I wanted to start talking about today was just some more calculator practice. Can you take out worksheet 8 and we're just going to do a couple questions on side A? Yep. Worksheet 8 talks about solving by graphing. So it's just more playing around with the calculator. The first method that I have demonstrated here is called the intersect method. That's if you were solving this equation right here. What is the left side of this if I were to graph it, guys? X minus 2 would be Y equals x minus 2? Parabola? No, y equals x minus 2 would graph as a line. Y equals 1/2 x squared plus 2 would graph as a parabola because it has an x squared. So if I want to use the intersect method, I don't move anything around. I just set y1 equal to the left-hand side of the equation and y2 equal to the right-hand side of the equation. And I find the intersection points. Now, when I find the intersection points, it is going to give me an x and a y. Which am I looking for? If this was my original question to solve this equation, what am I looking for? The x. Is there a y anywhere in this equation? No. All right, so let's go to the calculator and type in y1 x minus 2 and in y2 negative 1/2. You could use negative 0.5. I'm just going to put parentheses around the 1/2. X squared plus 2. Okay. This kind of a question, when I have no limits on what x and y can be, I would just start with a standard window. Okay, what's the standard window? How do I get there? Yeah, zoom standard or zoom 6. Did you put in? Did I type it in right? Does someone else's look like this? Okay. So we're looking for the two intersection points. So how do I do that? Second, calculate, choice 5. As long as I only have two equations in, I can just hit enter, 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 and it'll find one of them. I got 2, 0. What is the solution to my equation if I found an intersection point at 2, 0? 2 isn't, because there's no y, remember, in my equations that I'm trying to solve. All right, if I go do this again, what do I have to do to find the other one? Okay, so when it gets to the guess part, I just got to be closer to the other point. So I'm going to trace over here, or I could literally type in a guess. It's over to the left, so negative something would take me over there. And I found negative 4, negative 6, yes? Okay. Which of those is a solution to this equation? Yes. So I'm drawing this super horrible sketch. Okay? It looks nothing like it, I'm sure. But we found 1 point here and 1 point over here, which was really actually at 2, 0 where they intersected. I don't care. Okay. Why did I only write 2 and negative 4 on the blank? This is what gets students. They want to write ordered pairs. We were finding the answer to this equation. Do you see, guys? We wanted to figure out where this was true, that this equaled this. So we want the x values. Does anybody know what the y value tells us? If I put a 2 in on both sides, what do you think each side would equal? 0. Do you see, this is telling me if I put a 2 in on both sides, they'd both equal 0. If I put a negative 4 in on both sides, they'd both equal negative 6. But the x values that made them equal were 2 and negative 4. Everybody okay? Are you comfortable using the intersection button on your calculator? All right, I'm going to skip down to number 3. Sure. Actually, let's do 4. Number 4 is looking mighty messy. If you want to do this by the method that they call the x-intercept method, means you got to get it to equal 0 first. So if I go down to number 4 and I don't want to find the intersection points, what do I need to do to make this equal to 0? You want to go all this way? I don't know. If I add 82x squared over here, I'll have 83x squared. If I subtract 99x over here, I'll have a negative 98x. if I add 33 to negative 9, 24, did I do that right? So I moved all of this over to the other side, so I had it 0 was equal to this. If I have anything set equal to 0 and I want to know where its solutions are, you don't get to use the intersect feature. Do you know which one you're trying to find? The zeros. So we're going to graph this and find the zeros. Now, this is a disgusting parabola. Look how scrawny it's going to be, right, with an 83 stretch. The good news is we can stretch our little screen to fit any size we want, right? If I do a zoom standard, well, at least I see something. Sometimes you don't even see anything in a zoom standard. What are the X values we're looking at? Really little, yes? So maybe between -1 and +2? So if I stretch my X window from only -1 to +2, is that enough to spread it out a little bit? That window would work, right? You could change the Y value, but can you at least see 2 distinct points? That's the big thing, is you want to see 2 distinct points. All right, so basically my window is -1 to +2 for X and -10 to 10 for Y. Anybody got a question? All right, this is what I would do. I'm not a fan of the 0 thing. So I would scroll around till I thought I knew where it was. I think it's around 0.3. So then I would go second trace 0. And instead of scrolling to the left and to the right, I would say my left is going to be 0.2. My right is going to be 0.4. It's somewhere in between there. And I got 0.3467. You can scroll. You can scroll to the left and to the right. I just get really annoyed at the scrolling thing. So I like to know where and just type in numbers to the left and to the right. If I use the scrolling this time, I'm trying to find this 0. I again choose choice 2 for 0. If this is about where I want to be, I need to scroll a few to the left, then scroll back till it's gone past to the right. Is anybody ever gotten an error that says no sign change or something? Yes, it just means you chose your left and right bound to both be positive or both be negative. So it can't find where it's hit 0 in between there. I got 0.834 is the other one. Anybody? Anybody not getting those? Can I help anybody? All right, so what was the difference in those? Well, first of all, which method do you like better? I like the intersect method. Do you want to know how to cheat? We could do this question by the intersect. Does anybody? Well, first of all, we could have left it the original way, right, without moving everything over. But what if it says equal to 0? Want to know the Hofbauer cheat? Put it, a student told me this, I will be honest. If you put in y2, y equals 0, which is just the x-axis, now could you use the intersect method to find the zeros? Because one of your equations is just y equals 0. All right. If you want to start working on 9A, you can tonight as well. 9A, you only have to do the circled problems. 7 is the homework. 9A if you want to get a little bit further. Got extra time tonight and you know you're not going to tomorrow night, you might want to do 9A. Extra time. Or you just love the calculator questions, so of course you want to do the calculator.